G'day everybody, WheresWally here. Well, if you haven't seen my R-proof video yet, I recommend you do. It's super simple, barely an inconvenience to measure and calculate the offset between the horizontal planes, and then to calculate the length of the Earth's radius given that offset in those planes. Well, I have had a lot of pushback from certain circles, so I think there's only one thing left for me to do. Now that I realise my R-proof is hurting their t-shirt sales. You know what it is? Do another one, of course. Well, this time, Wolfie and myself, we measured moon angles. And this is what we saw. Now, Wolfie was in Sydney, as always, and he had his Uber sextant pointing at an elevation of 28.4629 and an azimuth of 7.94 degrees. Now, Wally, that's me, in Brisbane, I had my Uber sextant pointing at an elevation angle of 34.6898 degrees and an azimuth of 6.66, yikes, degrees. And this was at the same time too. So firstly, let's have a look at how well this works on a plane. Now we have two angles and a distance between them. Now one thing I like to do with flat earthers is just put this little thought experiment to them. We can assume that 10th man, say, if he was standing right beside me or Wolfie, he would be reading the same elevation angle to the moon with his sextant. Just not as accurately, of course. Tell me I'm wrong, Nathan. I dare you. Oh, wait, yes, I've already done that, haven't I? Now, Flat Earth has taken to insisting that there is a 90-degree over there at the GP of the moon. Well, okay, that's fair enough. And that there is a flat baseline between the observer and the GP. And that's not fair enough. We also know the declination of the moon, and that's the latitude of the GP of the moon. I get this from the Nautical Almanac. As both of our measurements were almost due north, we can once again ignore the azimuths. So now we have a simple 2D problem. The difference in the degrees between both Uber sextants and the GP of the moon are as follows. 26.89 north of the equator, that's where the moon was. To that we add the latitude south of the equator. So the two angles are 54.25 and 60.29 degrees. Now the distances A and B to the GP of the moon from Sydney and Brisbane, you can calculate this according to celestial navigation principles, and these are given by the delta in degrees multiplied by 60 to give nautical miles. Now we have two angles, and we have the length of the non-curve adjacent side, so we can solve this triangle. Well, don't believe me, let's go and ask a flat earth sextant expert. Take it away, Brian.
Now, here is an angular size measurement, right? He doesn't understand the difference, like most of the rest of our opposition, the difference between an angular size measurement and an elevation angle. If I know the height, the exact height of the Eiffel Tower, and I take an angle to the Eiffel Tower, I can then determine my exact distance from the Eiffel Tower based on the angle I take, because I know the actual height. If I don't know the actual height of the Eiffel Tower, but I know my exact distance from the Eiffel Tower, my exact distance, I can then, with my angle, determine the height of the Eiffel Tower because I have the distance. So you have to have the size to know the distance, or the distance to know the size, right? That's how it works. Surveyors use it all the time, or they used to anyway. They still do. They just don't need to do as many calculations, but that's how it works. You don't know what height this is, so you can't, and you don't know what distance you are from the GP. So you don't know what's the height of the celestial body, and you don't know what distance you are from the GP of the celestial body. You never find out the height of the celestial body. You just find out where the distance of the GP, and you find out then from the almanac where the GP is, blah, blah, blah.
Okay, a whole lot of wow. Anyway, here we go. Let's solve them both, shall we? However, we do get different heights for the opposite side. The length of the opposite is not the same. So, according to Flat Earth, the moon is simultaneously at 4,172.6 kilometres high and 3,631.9 kilometres high. Oh dear. It appears that Flat Earth is broken. Now, Wolfie and I, with our matching Uber sextants, on the night of the 12th of March 2022, we both measured the angle to the moon at 9 UTC. Now, let's get to the calculation, shall we? This is as simple as the difference in the elevations, which is 6.2237 degree, added to the difference in the declination, which is 0.0548 degrees. That gives us a value of 6.2786 degrees, and this is how far the horizontal planes at the ubersextants are angularly displaced from each other. It means they're not parallel, Bev. That also must imply that each horizontal plane is a tangential plane to the surface, and as it is known that each horizontal plane has a vertical line at the point of contact to the surface, and further, that this vertical line is projected down and must pass through the centre of the Earth. Now, the great circle distance between the two ubersextants is 696.198 kilometres. So once more we have an isosceles triangle of Fe doom. The distance below the surface that these two verticals intersect is determined by solving that isosceles triangle, the sides of which are 6,356.524 kilometres long, and that, my friends, is just 0.25% from the latitude adjusted average value of R, 6,372.651 kilometres. Now, I call that a definite win. Now, no flat earther can debunk that simple maths. No flat earther can debunk that simple maths, the zero assumptions needed, and the lack of concepts stolen to make this obvious measurement and calculation of R. And thanks to Wolfie for sending me the gear for the hours of logging onto my ubersextant in the middle of the night, uploading apps and sharpening the tool chains. It's really appreciated, mate. We really should do this again, but this time let's get global. Let's get truly international. Are you game? What say you, Wolfie, mate?
Thanks, Wally. I'm currently at Sydney Airport, and this is the United Airlines Boeing 777 that will be taking me to the United States today.